Let's say you wrote a program, but it runs too slow. So you run performance measurements and you find that your program is doing a lot of cache misses. You know that in some cases, changing the schedule of operations using techniques such as loop tiling can greatly improve the I/O cost, that is, the number of transfers between memory levels. So you run a polyhedral compiler on your program. If it succeeds in tiling your program, removing the data movement bottleneck, you're happy. But what if it doesn't? Maybe the I/O cost can still be improved by some manual transformation, or maybe I/O is an inherent limit of this program. Our tool IOLB helps answering this question by automatically computing a lower bound on data movement costs. If this bound is high, then this proves that the program is I/O limited and cannot be improved by changing the schedule of operations or the memory allocation.
In this program, we want to know whether the value of VA can flow to VC. Many program analysis applications use stack reachability formulation to capture matching conditions. Here, we want to track two matching conditions simultaneously. We need one DIC language to track calls and returns, another one for field assignments and accesses. This requires us to formulate the problem as an interleaved DIC reachability problem called inter-DIC reachability. Inter-DIC reachability problem is undecidable. One can only use approximation algorithms to provide safe answers. To improve the performance and precision of inter-DIC reachability problem, many previous efforts focus on proposing different approximation algorithms. We attack the problem in an orthogonal direction. We focus on simplifying its input graphs. Working on a simplified graph, inter-DIC reachability algorithm have a much better performance. By removing some false positive pairs reported by approximation algorithm, simplified graph can also help increase precision. If you want to know more about the topic, come to the talk on Friday, 16/20.
This is a paper on the static analysis of Java enterprise applications, and it's going to focus on what we call the elephants in the room, namely the precise and scalable modeling of diverse frameworks as well as cast data structures. Here are the contents of the paper as a word cloud, and you will see some familiar terms such as the Spring Framework and dependency injection and perhaps enterprise Java beans. And at the same time, you will see static analysis terms such as mock objects and context sensitivity. So why work on enterprise Java applications? They are at the same time the biggest success domain of Java and a major failure domain of Java static analysis because past techniques have not modeled them very well. The techniques we introduce here consist of a new vocabulary for modeling frameworks, an implementation technique for scalable and precise modeling of key data structures that we call sound modular analysis replacement, and then benchmarks that can be used to evaluate all of those and for which we get comparable coverage as for desktop Java applications. So come to our talk to find out more.